So we're going to have a look at what the dot product is and how to calculate it. So if we're given two vectors, a and b, in component form, so we've got a equals xa, ya, za, and we've got our vector b also in component form, xb, yb, zb. The way that we calculate the dot product is as follows. So we look at corresponding components. So the corresponding x components of a and b are xa and xb. We multiply those two together. And then we add the product of the y components of our vectors, so ya and yb. We multiply those together, we add. Okay, and then we also add the product of the z components of our vectors, za multiplied by zb, and that gives us this. Okay, so this formula we can use to calculate the dot product of a and b. So let's go through a numerical example. Let's suppose that a is equal to 1, 2, 3, and b is equal to 4, 5, and 6. Okay? So if we wanted to calculate the dot product, we're going to use this formula here. Okay? So we look at corresponding components. So the x components are 1 and 4, so we multiply those two together, and then we add the product of the y components. So our y components here are 2 and 5, so we're going to multiply those two together, and then our z components, 3 and 6. Multiplying those together and we're adding. Okay, so what does this give us? We've got 4 plus 10 plus 18. Okay, and this is going to give us 32. And the reason why this is particularly useful is because the dot product is also defined as the product of the length of A, so the modulus of A, multiplied by the length of B, multiplied by cosine theta. And theta is the angle between our two vectors a and b. So here's my a, here's my b, and here's my angle between the two vectors. And so if we calculate the dot product of a and b, and we obtain a scalar, a number, we can use this to calculate what the angle is between a and b. So in this example, what we need to do, or what we have actually, is we know that the dot product is 32, so we know that 32 is equal to the modulus of A times the modulus of B times cosine theta. Okay, which means we can rearrange this to obtain an expression for theta. So we've got cosine theta equals 32 divided by the modulus of A times the modulus of B. Okay, and this therefore gives us that theta is equal to inverse cosine of 32 over the modulus of A multiplied by the modulus of B. Okay? So all we need to do to find theta is to calculate what the length of our A and B are. So let's just do this right at the bottom. So our modulus of A, what we have to do to find the length of our vector A is we have to square each of the components and we have to add them together and then square root. Okay? So we've got 1 squared plus 2 squared plus 3 squared, and then we're going to take the square root of that. Okay, so what does that give us? So we get 1 plus 4 plus 9 and the square root of that, okay, which is going to give us the square root of 14. We can do the same thing with b. Okay, so for us, our components in b are 4, 5 and 6. So to calculate the modulus, we do 4 squared plus 5 squared plus 6 squared and take the square root. Okay, and this is going to give us 16 plus 25 plus 36. Mustn't forget the square root. So this is going to give us the square root of 77. Okay, so now that we have the modulus of both a and b, we can substitute that into our expression for theta. So this is going to give us cosine inverse of 32 divided. Now our modulus of A is root 14. Our modulus of B is root 77. Okay, and if we plug this into the calculator, what we should obtain is that theta is equal to 12.9 degrees to 1 decimal place. Okay. So this shows how we can calculate the dot product from two vectors in component form and how we can use that to find what the angle is between the two vectors.